it's harder to grade. So I'm hoping you take advantage of that. And I sent everyone the directions for how you can see your tests online. Please go back and look at your tests to see what you missed.
Yeah, basically, I would say, yeah, if they're not making 100 on their homework assignments, there is something they need to look at. If there's any reason why I'm not giving you 100, like, and even in like rare cases, you might make 100 and there might still be like a little thing that I just like felt really nice that day.
And I'm the same way. So even if you get a 99 or 98 or a 95 or an 80 or a 70, please go back and look. Don't go, oh, good, I just passed it. That's not the point of the homework at all. So go back and look at it, because we're making comments to you and telling you stuff that you need to know. And the same thing with the test. I lost my train of thought here, but we're going to, it's not going to get any easier. So please look at your homework, do your homework, and look at the comments that Matt and I made. And like I said, I gave you directions that you can look at your test. Make sure you look at your test. Number one, I could have added up the points wrong. Probably not, but it does happen. So you might want to actually go back and count your points. And if you go, oh, well, I should have got a 92 instead of an 89, then let me know and I'll fix it. Now, if you get a 95 and you should have gotten an 85, don't bother telling me that. That's okay. But if you catch something that I've done wrong, I'm more than happy to make that correction, but you have to let me know. If you want to argue about something like you think I'm wrong about something, if you make a habit of doing that, then I don't get too happy about it. But occasionally, I don't mind it if you really are convinced that you really have the right idea. I don't like grade grubbers, so don't do that to me. Otherwise, it will not work in your benefit. Okay, so I want to first go over a few test taking strategies with you, and I'm not spending a whole lot of time on this, but I just want to make sure, and I sent this to you in an email again. So here are some strategies that you should probably be thinking about before you take the test. The number one thing is consistently come to class and consistently do your work. And if you do that in this class, because we meet every single day, then you're going to be in good shape. I can promise you that this class is probably going, if you need a math credit, this is the class to be in. You're not going to find one that's going to do you any better than this class. I promise you that. So hang in there, and we will do everything we can to get you through. We want every one of you guys to be successful, but you have to do the work and you have to do your part. You have to meet us, and not just in the middle. You have to do over the middle. You have to come to us. So these are test taking strategies. Again, if you want to read them, I've emailed them to everybody. This is like a little checklist of before the exam, what I thought I would receive roughly, and what you did to achieve what you were going to do, and the mechanics of studying, and who you studied with, and the time of day you studied, and how much time you studied, and then during the exam, what you thought, and then after exam, what you thought, and was it what you expected? And then some things that you can do maybe differently on the next exam. So these are all things that I would like you to look through, because I think it's really helpful to analyze what you don't know and why you don't know it, and why you're doing what you're doing and what you can do better. That's my point on this. Hopefully everyone has watched the videos always and takes notes. And so the first thing we're going to do is go over the properties of exponents. And hopefully everybody watched this. And what we're going to do, take out a piece of paper, if you will, and have your pencil ready. We're just going to go through some quick flashcards to see if you just know the basic rules of exponents. So this is kind of like a little self-test. And so everyone, I hope, participates in this, because and then I also posted these flashcards for you on the website. So pull over here, whoops. Okay, you have to memorize these. If you don't, it's not going to be pretty, I promise. Okay, so here's the first one. I'm going to give like 5 or 10 seconds. So it's either you know it or you don't, because they're that basic, okay? A to the m times a to the n. What would that simplify to? And then after I do that, I'm going to give one with not just the variable, but with a number in it. So a to the m times a to the n is a to the m plus n. Okay. So what would, and that's ugly, I know, sorry about that. What would 5 to the 4th times 5 to the 3rd be? Can someone tell me? Quickly, quickly.
5 to the 7th?
Thank you. Yes, 5 to the 7th, because you keep the base, add the exponents. Okay, a to the m divided by a to the n. This is the rule. Everyone should know it. If you don't know it, then make sure you do by, you know, like yesterday. So a to the m minus n. You keep the base and subtract the exponent. So what would 5 to the 8th divided by 5 to the 3rd be?
5 to the 5th?
Yes, good. Power rule. Power rule, when you have a base and an exponent that's raised to a power, you multiply the exponents. So what would 5 squared to the 3rd be?
5 to the 6th?
5 to the 6th. You multiply those exponents. A times B to the n, the product to a power rule. You don't necessarily have to know the names of these rules. It helps because I will refer to them sometimes, but you have to know what to do when you see this. So when you do that, you're going to apply the n to both the A and the B. People want to call that the distributive property. It is not the distributive property. The distributive property is only for multiplication over addition and subtraction, but you are applying the n to both pieces. So what would, so it's A to the n times B to the n. So what would 5x in parentheses squared be? Anyone?
5 squared times x squared?
Yes, sir. 5 squared times x squared. And that was easy enough to simplify. So you could go ahead and simplify that. If it was like 5 to the 10th times x squared, I wouldn't expect you to. Quotient rule. Again, if you have a quotient to a power, you're going to apply that power to both the top and the bottom of the fraction. So that would just be a to the n divided by b to the n. So what would be 5 divided by x squared?
$25 over x squared?
Yes, sir. 5 squared over x squared, which is 25 over x squared. Negative powers. You're almost always going to be asked to leave your answer not having a negative power. The negative power just tells you to take the reciprocal of whatever the base is. So this negative n tells you to reciprocate a. So that would just be the same thing as 1 over a to the n. So it would be 5 to the negative 2nd.
Uh, 1 over 5 to the 2nd?
1 over 5 to the 2nd, right, which is 1 over 25. If you have, again, if you have a negative in the denominator, that tells you if you want to get rid of that negative, you flip it. And once you've done that, you take the reciprocal, then the exponent becomes positive. So 1 over a to the negative n is the same thing as just a to the n. So what would 1 over 5 to the negative 2nd be?
$25?
25. If you have a fraction to a negative power, again, remember, anytime you have a negative power, that has nothing to do with whether the expression is positive or negative. What it's doing is to tell you to take the reciprocal. And once you've taken the reciprocal, then that exponent becomes positive. So that would become b over a to the n. So what would be 3 over x to the negative second? Anybody?
I guess the top would be +9, right?
Okay, so what does that -2 tell you to do? First of all,
Oh, wait, no, you're dividing, right?
right?
All right, so that would be 3 over 2 then at the top?
Okay, so what the negative tells you to do is take the reciprocal of the base. What would be the reciprocal of the base?
No. No. X over 3 then.
Yes, x over 3. And once you've done that, now the 2 becomes positive. So you got x over 3 to the positive 2, right? And what would that be?
X squared over 3 squared.
X squared over
Squared.
3 squared, yeah. X squared over 3. So when you flip it, it becomes x over 3 to the second power, which is x squared over 3 squared, which is x squared over 9. Anything to the 0 power, what is that? Anything.
Well, it has to be 0 because you're not, or no, it's itself, isn't
No,
it? It's its own number. It doesn't change.
no. It's a definition, and you'll see why it works. But anything to the 0 power is always, does anyone know?
1.
Yes. Anything to the 0 power always is 1. Always 1. And if you think about that, when you subtract exponents, let's say you had 5 squared divided by 5 squared. And you subtract the exponents, 2 minus 2 is 0, and then you get 5 to the 0 power. And anything divided by itself is 1. So that's why that's defined that way. All right, so what would be this ugly glob to the 0 power?
Is it 1?
It is 1. And you guys, if someone tells me on the test that something to the 0 power is 0, I'm going to count off. You'll get negative. You'll get, like, if it's a 5-point problem, you'll get 10 points taken off. Okay, so now let's go back to, okay, so that's just a quick review of the exponents. So now we're going to go to the book exercises. I'm going to pull them up real quick, and we are going to get into groups, and I'm going to want you to work through those book exercises, and we'll come back and go over them. So let me pull those up. Guess I don't have them. Okay. Get them. Written. Do not have the book exercises. Okay, let's pull those up. Okay. So these are the book exercises. And there is one more that I didn't put on here that we're going to go over together in class. It's an application problem regarding scientific notation. So after we come back together, we're going to go through these and make sure everyone has them right. And then we are going to briefly review scientific notation and go through a scientific notation application problem. If you, hopefully everyone has a scientific calculator, we're going to talk about some of the easy ways you can make this section a little bit easier for yourself when we get to the scientific notation. Okay, so let me put y'all in groups, breakout rooms. How many people do we have in class right now? 10. That's horrible. Okay, so we'll go 3. And I'm making you a co-host, Michael, so you can, I'm not Mike. Oops, didn't mean to do that. I meant Matt.
Oh, we can hear you.
Okay. 5-2 homework.
So which ones are we doing?
I don't know what she told you to do.
They work on the book problems. They didn't really specify which ones.
Yeah.
We're doing 5.2. I mean, the first page generally looks easy. It's mainly just addition and subtraction. I guess I should start by asking, does anybody know what they're doing before we get started?
Yeah, a little bit.
Good. All right, well, let's go ahead and get started with 81. We all know multiplication is really just addition. And luckily, some of them are variables and still numbers. So D times D3 times D6, I got D9.
That's what I got too.
Okay, next one. Try to roll these really quick. 4 and 5x times 4 and 9x, I got 14x.
4.
Yep, that's what I got.
Okay. Sorry guys, one sec. I got people working on the voice. All right. 2y times 4y to the third. For that one, I got 8y to the fourth. I have a little question on that one, but I just want to know what you guys got on it.
I got the same thing.
8y to the fourth?
Yeah.
Okay. For this one, w times w2 times w3, I just got w5. Anybody agree, disagree?
You got W5.
Yeah.
Okay.
Again, C and D, I don't even know if they're correct.
What
What
about
is-
the other W that has a 1?
Yeah, what's the exponent on that first W?
Yeah, I got
One.
W6.
Yeah.
Yeah. All right.
So this is like, well, you have to start hallucinating or something. I don't know. So you have to start seeing things that aren't there.
Yeah.
Yeah, I did see correctly. It's like 2 times 4, so you have to multiply the coefficients, but you add the exponents. I think that weirds people out sometimes because it's like you're doing 2 different operations.
Yeah.
But y'all did it right. 4 times 2, and you do 3 plus 1. Yeah.
All right. Anyone want to do 87, or you guys want me to do it? I mean, I already got the first page finished. I just don't want to hog up all the time here. I'll interpret that as a no. Okay.
Can I go back to this?
87. YA times YB. I just got YAB. Disagree, agree? Anyone?
I got Y, A plus B, but
I mean, like I said, I don't know if 87 works or not, but that's just what I got. We're adding them, but you can't add 2 different variables without a coefficient. So, I mean, they could just mean the same thing. Okay. Well, when we goes through them, I'll make sure I'll ask about 87. For 89, that is just straight up subtraction. I'm sorry, give me a minute, please. Someone climb my door. What? Okay, sorry. 89 is straight up subtraction. So, real quick, anybody want to do 89? Or you guys want me to do it? That's what I like about you guys. Always giving feedback. Okay. 89a. 15 over x over 3. I got x equals 15. I'm sorry, x to the 15th.
mm,
Yes, no, maybe, so.
I got the same thing.
Awesome. Who's speaking, by the way?
It's Olivia.
Olivia, thank you very much. I appreciate you. Okay, it's not talking to the air. All right. So 89b, 512 minus 53, 59.
Mhm.
Sorry?
I got the same thing.
Okay. For 89c, I got q18 over q36, and I got q negative 18.
Do they want you to write them with positive exponents?
Okay, so, all right.
They might want you to, I think. Typically, they want positive exponents, which you're right is q minus 18 if you put it on top.
Awesome. That would mean d is 10-1 then.
1/10, right? Is that what you're saying?
Right.
Yeah.
Yeah.
Mhm.
And c would be like 1 over q to the 18. You got to flip it over 1.
Mhm. Okay, 93. Can anybody do 93?
I mean, I got 1 for both.
Awesome. We're good. Awesome. Right track. Excellent. 97. I'll tell you what, I'll do C and D. A and B are they're pretty darn easy. So does anyone want to do A and B?
For A, I got 1 over A to the negative second power.
Awesome. You said 1 over A to the second power?
No.
It should become positive when you flip it.
Yeah.
Oh,
I know you
okay.
did. You said A to the second power. Okay.
Cool.
Anyone want to do B? It's really the same thing as A.
Yeah, I mean, I don't know. Ooh, I guess this is my test, huh? So if you have like 1 over 10 to the third, typically I would write that 10 to the third out as like 1,000. It's not too hard to do. And typically if you have a number, like you can and it's a number to a power, you can like expand that out to the number. It depends how large the number is too. If you have like two to the million or something, it's gonna be like crazy, right? Like 2 to the 20.
On paper. All right. So can we just keep it as like a number and an exponent, or do you know we got to write it all the way out?
For like things small enough, like 1,000 or something like that, it's probably better to put it as 1,000.
All right.
But I mean, that's kind of like one of those things that might depend upon the case, and you might have to use a little discretion on like what we're talking about.
Okay. All right.
To give you a non-answer, but not that.
It's all good. It's all good. Where were we? Right. Sorry, a little side note. Okay, 97C. So 1 over C to -5. I flipped it. I got C to the 5th over 1. Anybody agree?
I got the same thing, but I just didn't put it over the 1.
Yeah,
Oh, yeah,
I just
definitely.
left the C alone.
I'm sorry?
I just left the C alone. So I just got C over 5.
Yeah, that'll work. I mean, generally, that's what I love about variables is you don't have to write them out. You can just keep them as a letter, which is nice. Sorry if I sound a little aggravated, guys. Just we're really had a mess over here today. People are still trying to get their crap cleaned up, get their crap together. Okay, 97D. 3 to the second power. 3 squared over 1. Real quick, before anybody says anything, do you guys know how we get 3 squared? Is anybody unsure how we get that? I mean, real quick, I can explain it. It's really just 2 steps. Kind of like I do reciprocals, you just do the same equation, but the negative exponent becomes a positive.
Mm-hmm.
Great. So what did you guys get for D?
Well, I got 3 squared, but I just turned it into 9.
Yeah, that can work. Usually, like what Mr. Seaver said, is that if you get an exponent, generally you just want to write it out. I'm just so used to writing the variables next to it. So yeah. All right. So, yeah, no. Olivia, yeah, you did it. You did it correctly. Okay, 101. Now for this one, since it's a -2, I just drew a 1 underneath it, and then I flipped it over, and it becomes 8 over 5, positive 2. Anybody not get that? Like I'm still on, like there's 3 steps this one, I'm still on step 2, so.
I mean, I got the same thing. I just, again, I made it 65 over 20 or 64 over 25.
Awesome, yeah, you did it. Yeah, that was the 3rd step. Now, I don't know if we're supposed to go any further than that, but I just kept it as 64 over 25.
Yeah, that's what I did too.
Great.
It's not going to reduce at all.
Awesome. All right.
Because 8 is nothing but 2s and 5s is nothing but 5s. So there's no common factor there.
Yeah, it's not going to come out even unless it's mixed. Okay, 101B. Olivia, want to give this one a shot?
I got A squared over B squared.
Awesome. Great. Fantastic.
Are we supposed to do the whole thing? Like all of 5.2, the book problems?
I'm sorry?
I don't think she ever told us how many we're supposed to do.
Now, she didn't really assign us any numbers. I just figured we'd do them all, you know? And if she asks us, like, how come we didn't do, like, problem 125, I'm just going to tell her, like, we weren't assigned that one, but we'll go ahead and do the ones that we did finish.
You got 4 more. There's only 4 more to do.
Yep.
We'll probably get there. We can do it.
All right. 109. E to the 4th. B minus 8. Okay. Sorry, guys. I'm just writing this all out. Minus 5. W minus 2. Parentheses 6c to negative third, d to 9, parentheses. Okay, perfect. 109A, real quick. Like I said, does anybody know how to use the product property? No. Okay, once. All right, now listen, guys. Don't worry about like if you get this wrong or right. We're now learning this, so if I get this wrong, I want to know I got it wrong, so I know how to do it right. If you guys get a different answer, please let me know because generally I am just going along on this. I don't even know it's right or wrong yet, so don't hold back. Okay. So 109A, B4 to B8. Now, if I'm not mistaken, I'm supposed to be adding these. So we can b minus 4, negative 4. Can't let that happen, so b to the 4. Okay, yeah, okay, so A, I got e to the 4th. If I'm wrong, call me out on it.
I got
1 over
1
b.
over 4. 1 over
4?
B4.
1 over B4.
That's what I got.
Fantastic, fantastic. So what I got was wrong. Finally, get you on to talk to me. So, how did you guys come up with 1 over b to the 4th?
Because since B was negative 4, to flip it to the positive, I put it through a fraction. So I just like flipped it over. That's in 1 over B4.
Boom. Awesome. Great. All right. Nice to hear your voices. Okay. All right. Wait. So real quick, everybody here. Bree, I haven't heard from you yet. Just want to make sure everything's all right. If your mic's wrong or something wrong with your mic, just go ahead and shoot us a note in the chat. But we're all agreed. 1 over b to the 4th, correct? For A?
Mm-hmm.
Awesome. Okay. Now, 109 to b. W4 x minus 5 times w negative 2 x minus 4. Okay. W2 negative 9. Okay. Now remember, if I get it wrong, call me out on it. Okay, guys?
Mm-hmm.
Okay. So I got w squared over x negative 9.
That's what I got too.
Awesome. Okay. Guess we're all agreed on that.
Yeah.
9 is c. Negative 6c to the positive 3.
Are you using negatives? Did you say negatives? Or did I hear that wrong?
Sorry?
What did you get for B again?
W2 over x9.
Oh, yeah, that's it.
Okay. Got me going there. I was like, wait. Darn it. Okay,
I'm trying to figure out like all these stupid little annotation things that I can do on here.
Hey, we're with you there. No, it's all good. It's all good. Do what you got to do. 109C, everyone. Negative 6C, negative 3, D9, times 2C fourth to D negative 5. Does anybody want to do this one? No?
Yeah, I'm not too secure in my answer.
It's okay. It's all good. It's all good. All right. I'll put myself out there. Okay, now I'm not really sure how to do with the coefficients, so I just added those two. No, scratch that. Multiply those two, and I got negative 12, C 1, and then for D, I got 4.
Yeah, I did get that.
Okay, good. We're on the same track. All right, so put that over 1. And since really I always said C1, but really it's just C. So really it's just be written out as negative 12C.
Yeah, I just wrote it negative 12 CD to the
Right,
fourth.
right. Just bad habit of mine. I keep on running the one exponent, man. I remember I almost got points taken off for that. Fuck me. Okay. D to the fourth. I put that as the denominator. We all good on that?
Yeah.
It's a denominator.
Mhm.
Yeah, like I said, if I did it wrong, call me out on it.
Well,
Did I miss a step?
did you got negative 12?
Yes, we did.
C?
Negative 12C. You got that.
And then D over 4?
D to the fourth.
So it should be 9 minus 5, right?
Yeah, 9 minus 5. is
9 minus 5 is 4.
4.
And is it positive or negative 4?
It's a positive 4.
And if it's positive, does it go on top or bottom?
On top?
Yeah, it should go on top.
Okay.
I mean, like we can draw that. Well, come on, line. Come on, line. If you want, you can draw like over 1, right?
Right.
And so they should stay on top as long as they're positive.
Well, that makes sense. Negatives go down and positives go up. It's just
Yeah. Or vice versa. If you have a negative on the bottom, it's gonna flip up, right?
right.
So if it's positive, it stays where it is. If it's negative, it gets flipped, kind of.
So is it like D over 4 and then the fraction negative 12C? Or do we just leave it like
It should just be.
negative 12C?
It should just be one line. Let's see if I
Okay.
can text. So like minus
Yeah, that
12,
was asking.
C to the first, and then D to the fourth. I can't do it,
Okay.
right? It should be just like one line. And this is all over. Let's see if I can draw. And this is all over 1, right? You don't have to write the over 1, but it's just kind of generally understood.
Okay.
Sorry, guys. Getting writing side notes here as we go along.
Ooh.
Okay. All right. So we're all good on 109. Any other questions?
Mhm.
No? Okay. 117A. Let me write this out. All right, parentheses 3. 5x to y. Q6 to negative 8. Okay, great. All right, so for this one, honestly, if I remember the video, this is just straight up exponent multiplication. So I got, for A, I got y 3x.
Yep, that's what I got too.
Yeah, me too.
Great. Sorry, guys.
It's an exponent of 3x, right? That's what we're talking about.
Yeah,
Yeah.
Yep,
the
yep.
exponents are 3x. Okay. Does everybody understand how we got that before we move forward?
Mm-hmm.
Okay, great. All right, now 5xy really is just 5xy.
Yep, that's what I got.
Okay. All this starting to sink in now?
Yeah, I got 5 at Y2.
I'm sorry, say that again?
That I got 5 at Y.
5xy, awesome. Okay. 117C. Anybody want to take this one, or do you guys want me to do it?
I got 1 over Q to the 48th power.
Positive 48?
Yep.
Awesome. Great. That's what I got too. All right, moving on.
You say
real-
1 over Q? Or did you say
Mhm.
Okay, yeah, okay. That's
121. -5. Sorry, guys. Wait a minute. I'm writing all this out. 3, 4. Q. -6x to the third minus 2. Okay. Let's see. Bree, real quick, that way I can tell Mrs. Watson that you were part of the script. Can you go ahead and tell us what the answer to B is? So the exponent is 0. One. Fantastic. Thank you, Bree. Glad to have you with us. Okay. I'm sorry for keep annoying you all by asking just real quick. Everyone know how we got 1, right?
Yeah.
Great. Okay, 121A. Real quick, does anyone want to do this, or do y'all want me to do it?
I got 125A to the third times B to the third.
Yep, so I got 2.
oh, what kind of 125?
I got
Positive.
well,
Should
I
it
got
be
negative
negative
15.
125?
Should be
See,
negative.
I put
Okay.
You're multiplying it 3 times, right?
Oh yeah, that makes sense. Yeah.
So you always look at whether it's like even or odd when you do negatives. So that one's odd. It's going to be an odd number. Negatives overall, it's going to be negative.
Mhm.
If you have an even number of negatives, they cancel out, right? Or they simplify out.
Yeah.
So if it's a square, it's always going to be positive. If it's a quartic, 4th degree, or 6th degree, or 8th degree, probably not going to go any higher than that. But
Mhm.
yeah, it's there.
So is it like negative 15 A over 3 and B over 3?
Oh, I'm so glad you said that.
Huh?
I'm so glad you said that because you said minus 15, right?
Yeah.
You want to be careful. Don't do that.
What do you
That
mean?
is a really common mistake. Like everyone makes that. That is a -5 to the third power.
Yeah, it's negative, right?
Yeah. So, but you have to raise it to the third. So it's not the same thing as multiplying. It means -5 times -5 times -5. Does that make sense? This is
Oh, I
equal
see
to,
it.
yeah. It means we have the -5 3 times is what it means. It's not -15. It's like what, -125, I believe.
right.
Oh, it's closing.
You have to be really careful because another way you can look at that is that's -5 to the first power right there.
So is it 125?
Yeah, so it should be -125. That is, you have to raise your constants to the power, but then your powers get multiplied, right? So there's 2 different operations happening here as well. We're raising powers to powers. Can you see my mouse on here?
Yeah, I can see it. But it's about to close in 5 seconds.
Okay.
Additional book problem, part of the homework, the
Yeah.
Pluto.
Right, it is. And we'll go over that right now. That's what we're going to talk about. Matt, did your group get through all the problems?
Mute.
We went through some of them.
We were on 121. I was on mute, sorry.
Oh, sorry. Yeah. So y'all got through most of them then. Okay.
Yeah, we were going into that issue of multiplying instead of raising to the power.
Right.
That -5. So that's a really common mistake, and we were getting on that.
Yes. So let's go through these last ones, and then I'll post all of these on Blackboard so you can see them. Okay, so again, guys, it's so important that you practice these. It's so easy to get confused if you do not have a good grasp on these. So on 121, we said to take that 3, that exponent, and apply it to every single part of the term inside of the parentheses. So that would be -5 to the 3rd, and then a to the 3rd, and then b to the 3rd. And then if you, -5 to the 3rd power is the same thing as -5 times -5 times -5, which is -125. A to the 3rd, b to the 3rd. On C, the negative power tells us to take the reciprocal of the -6x to the 3rd. So that would be 1 over -6x to the 3rd to the 2nd power. And if you square the numerator, that would become 1. If you square the denominator, that would become 36. X to the 6th, because you multiply the 3 and the 2. And then on D, if you apply the 2, 3 squared is 9. Multiply -4 and 2, and you get y to the -16th. You don't want any negative exponents left in your answer. So if you have a negative power in the numerator that's with the y, to change it to positive, all you have to do is flip it into the bottom. That's like taking the reciprocal. So your final answer is 9y to the 16th. Remember that negative power that only goes with the y. So don't pull the 9 down with it. And then on 125, you're applying that 4 to every single part of that fraction. So a to the 4th, 3 to the 4th, and b to the 4th. I don't mind if you leave it like that. If you take 3 times 3 times 3 times 3, it's 81, b to the 4th. And the same thing with C, you're going to apply that 3 to every single part. So we would get 2 to the 3rd, x to the 3rd, y to the 6th, over z to the 3rd, and you can simplify that. Or you can, 2 to the 3rd is 8, so you can keep going if you want. Oh, on B, I forgot B. Did I do B? Flip it. Square every part, and you wind up with 16m squared over 25. And finally, D, if you apply the 2 to every single part, 4 squared is 16. Multiply the -3 and the 2, and you get p to the -6th. Multiply the 2 with the 2 on the q, and you get q to the 4th. That p to the -6th, you don't want to leave it like that. So to change it to a +6, you flip it down into the bottom. I told my group I'm going to give you some extra practice problems. I'll post them on Facebook. I mean, on Facebook. I'll post them on Blackboard, and I'll put the answers. I would really recommend that you practice more than the 10 problems or whatever it's given on the written homework. Another thing, Matt probably told you this too, but I want you to be very, very careful. If you have something like this, 5 to the 0 power, that is 1. Anything to the 0 power is 1. But if you have something like this, -5 to the 0 power, that 0 only goes with the 5. It does not go with the negative unless that number's in parentheses. So this would be -1. But if you had this, -5 to the 0, now it's back to 1. So be careful with those.
We don't talk about the 0 to the 0 in here, do we?
No.
I think we just avoid 0 to 0. It's like, no. There's different interpretations. It can either be 1 or 0.
Yeah, there's the.
Yeah.
Is it like no solution or something?
No, It depends. You can interpret it either way, and both ways have their what do I want to say? Have their usage, right?
Yeah.
So it depends what you're doing. Sometimes we interpret it one way, sometimes we interpret it another.
Yeah.
I really think we still have not standardized enough of algebra. When I'm reading it, it just seems like it's some kind of cobbled together mathematics that like different people just sort of contributed stuff to it.
I know, but
Nobody really
It's
standardized
pretty
it.
standardized. There's not very many, you know, that's why 0 to the 0 is interesting, because there's not really very many ambiguities in math.
I would say look at like something like Peano's axioms, where he axiomatizes the like I think he's axiomatizing the natural numbers in there. But yeah, it is based upon like, it boils down to self-evident axioms, right? Is what it all boils down to. It's an application of logic, and so you have to base it upon something really simple. And those axioms, they have definitions in there as well. They're where we start defining objects. And so we put these axioms together deductively, right? Like the cliche examples, like all men are mortal, right? Socrates is a man, therefore Socrates is mortal, sort of thing. There's like a structure to the way that thing is assembled, right? And that's what we do with axioms. We assemble different axioms to get to math theorems. And so you have to use your axioms and deductive logic to prove your theorems, right?
Okay, so let's look at scientific notation. Tomorrow we're going to go back, because the exponent stuff is, to me, it's like if you don't get these exponent rules, you're just gonna fall way behind. So we will take some time tomorrow. It's a short day to go back over exponents, and we may spend, who knows, most of the hour on that. And then the polynomial. So if we don't get through tomorrow's assignment, then that homework won't be due till, we'll talk about that tomorrow. Anyway, so, but I want to talk about scientific notation, which is, people like, why would we ever want to do this? Well, it's because we're working with such huge numbers that sometimes it's not, we don't want to write them out all the time. It just doesn't. Now this one's not really going to matter because it's so ugly. It's going to still look ugly even in scientific notation. But oftentimes that's not the case. So you should be able to go from an actual number into scientific notation, and from scientific notation back to the actual number. So remember, with scientific notation, in the first spot, in that spot right there, it has to be one number, and it can either be a 1, a 2, a 3, a 4, a 5, 6, 7, 8, or a 9. Okay, so it's got to be, or a negative, or all the negatives. So it's got to be an integer right in there. And just one number. So you can't have 2 or 3 numbers. It's not in scientific notation. It doesn't even matter. It's not. If it's got 2 numbers in front of the decimal, not scientific notation. So to write this in scientific notation for this one, you know you'd have to have a 1.05002. I don't know where I wrote this ugly number, 3222042. And you don't need those zeros on the end. Times 10 to some power. And to determine what power, you would count how many times you would have to move the decimal in order to get, so the decimal is right here, even though it's not written. So you'd have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times to get it where you want. So this would be 10 to the power of 17. And if you think about this, this is a huge number, 105 what? Zillion plus.
Quadrillion, it looks like.
Quadrillion, thank you. And we're going to a really small number, like $1.05. So to balance them out, because if you had a trillion, $105 trillion, and someone gave you $1.05, that would not be fair. So to balance it out, you have to make it 10 to the 17th. So here's a little bit better one that's not so long. The number that has to be in front, it doesn't have to be a 1, it can be any number, but this is going to be 1.07862. And I really should have given one that was, anyway. So here you just move it one time. So that would be times 10 to the first. Now in your calculator, it looks exactly the same. Like if you get these huge numbers, a lot of times the calculator can't handle all of those numbers or doesn't want to, or you might not want to write 10 to the 17th. So what it'll give you is the 1.05 blah, 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 blah. And then instead of times 10 to the 17th, depending on your calculator, it'll either go E17 or double E17. So this one would be 1.067682 E10. E1, sorry. It's always the exponent. The E stands for the 10 to the power. So this one, we want the decimal point here, so it's going to be 1.23405. And this time, we're going the other way to get it. We're going to the left, to the right, the other left. We're going 1, 2 to the left. So this is going to be times 10 to the what?
Negative second?
Yeah, right, negative second. We're going from a small, really small number to a bigger number. So that's why it's 10 to the negative second. You can always check yourself on these on the calculator if you're not sure. It's easy to get confused about which way to go.
Okay, so positive goes right to left, negative goes left to right.
Yeah.
Hmm.
So here we have, so this would be, if we wanted to write it, see how it would be on the calculator, it would be 1.23405 E negative 2, double E negative 2. All right, so then if you're given in scientific notation and you want to go the other way, if you want to go back to the actual number, this tells you to move it 4 units right, to the right. So that's going to be 62100. Any notation or calculator, it would be 6210 E4. So this one would be, here we're going the other way. We're going to move it 11 places to the left. This is one like you can tell for sure. You wouldn't want to work with this number, not in scientific notation more than likely. And I don't know how many zeros that is, but I don't know. And then these are the same. It's just that this would be 3.056 times 10 to the 5th. So that would be 3.05600. And this would be 9.8765 times 10 to the negative 6th. So that would be 0.123459875. Matt, I know you taught this already, but do you have any tips for them on this or anything I haven't mentioned?
That's about it. This is a weird thing where we might have to move it like 1 decimal place if they're doing it on like the calculator. I think that thing is like, that's probably like the most common thing that trips people up, I think.
Right, and we're going to look at one like that right now, actually. This is the last book problem for homework. And actually, I accidentally put it 2 places. So this is the last book problem, but I also put it on your written exercises. So it's the very last problem on the graded exercises. So you'll get 4.5 or 5 points if you just copy this onto your homework on the written exercises. Okay, so the distance from Earth to the sun is 93 million miles. And honestly, guys, I really think that a lot of scientific notation is like, if you're working with huge numbers, like you're trying to send a spaceship to Mars, you're working with huge numbers, then you're gonna, and you want to be exact as you can possibly be, you're going to be using a lot of scientific notation. If you're working with really small numbers, like I guess brain surgeons, you know, you don't want to even be even a teeny tiny little bit off. So you're going to be working with super, super small numbers. So a lot of times that's where scientific notation can come in handy as well. All right, so the distance from Earth to Sun is 93 million miles. I'm going to actually write this out. That would be 93 million. That's 93 million, right? So 93 million is the same thing as 1 AU, which is an astronomical unit. I don't know where they came up with that, but some scientist, some astronaut. Pluto is 39.5 AU from the sun. So what's the distance in miles? So what am I going to do with this 93 million? What am I going to do with it?
Well, it equals 1 AU, so we already know what an AU is.
Right. And we know that Pluto is 39.5 AUs. So what are we going to do with that 93 million?
Just substitution.
So if you have 1 AU, that's 93 million miles, right? If you have 2 AUs, that would be 2 times 93 million miles.
Yeah, just substitution, just like a linear system.
I guess I'm asking what it would we multiply 93 million by?
Well, 39.5.
Yes, and that's going to give me, so this is 93 million miles, right? Times 39.5, which is 93 million miles is 1 AU, and we have 39.5 AUs. So I'm going to multiply by 39.5. So let's just for grins change both of these numbers to scientific notation. So how would you write 93 million in scientific notation?
9.3 times 10 to the 7
Yep.
power?
Yep. How would we write 39.5 in scientific notation?
You mean 39.5 AU?
Yes.
Yeah. Or whatever this solution is, whatever that number is.
How do you write 39.5 though in scientific notation?
If we're multiplying it by the 93 million number?
No, I'm just looking at this number right here.
Oh. I guess that's 3.95 times 10.
Yes. Okay. So now I'm going to multiply the 9.3 because multiplication doesn't matter the order that you do it in, right? You can multiply in any order that you want. So I'm going to multiply the 9.3 and the 3.95. So 9.3 times 3.95. I'm just going to rearrange this. And anytime there's no exponent, it's implied 1. So 9.3 times 3.95 is 36.735 times 10 to the what?
To the 8th?
Yeah. Is that scientific notation?
No.
No. Why not?
There's more than one number in front of the decimal.
There's more than one number in front of the decimal. So how am I going to fix that? I think this is what Matt was talking about. It can get kind of confusing.
You would lower the power of 10 by 1, right?
Okay, so first,
In
let's
this
go
case,
with
it would be increase, I guess.
So this, where would the decimal point be on this piece right here if it was in scientific notation? Between what two numbers?
3 and 6.
3 and 6. All right, so we went from a big number to a smaller number. So how am I going to make up for that? What am I going to have to do with the 10 here?
I would add one more power to it.
Yes, yes. Right, exactly. Because to balance it out, we're going to have to make that a bigger power, right? Because we took the number 36.735 and we wrote it as 3.6735. So we went from a big number to a smaller number. So to make it to where it's equal to the original, you have to raise that power on the 10. 1 power. Okay.
One goes down, the other one goes up.
Yep. And if you ever want to check yourself, take your calculator and do this. So on the calculator, you could do 36.735 E10.
E8.
And then, oh, E8, thank you. E8. And then you could try 3.6735 E9, and those should come out to be the same thing. Okay. All right, so we're through for the day. We've kind of gone through it pretty fast, so we will spend quite a bit of time tomorrow going over exponents some more, and then start the next section probably, which is adding, subtracting, and multiplying polynomials. We may just get through part of that. So are there any questions?
Is there any time when one is preferred over the other one, like an E instead of the 10?
No, it's just that your calculator, when you put it, a lot of times if you put really big numbers in, it will write it in scientific notation, and that's how you write it in scientific notation. I mean, that's how the calculator does it. Yeah, when you're writing it on your paper, I want you to write times 10 to a power, because that's correct scientific notation.
Do we go over a section with metric measurements in this class? I can't remember if it's this class or the other one.
I don't think we do.
This makes metric really easy.
Yeah, we need to switch to the metric system already, man.
We should. Well, we've been
so
saying that
backward
for
in this
60
country.
years.
Yeah, we're totally backward in America, man.
Well, we are, but it would, I don't know. People are so set in their ways. Yeah. And it would cost tons.
You'd probably have people with assault rifles marching outside the Capitol or something if you tried to.
Oh, I'm sure that would happen, but
people out there with AR-15s or something.
Yeah, but think about we'd have to change so many things. Like
we need to just do it already. The more we wait, the worse and worse it gets. Like NASA, one of the famous examples is that probe that crashed into Mars.
Yeah.
Because they couldn't standardize their feet and meters or something like that. So yeah, I mean.
Yeah, you just need to bite the bullet.
Yeah, we need to do a lot of things.
Yeah, and I mean the whole pushback on that is just it's tradition. Like there is no like logical reason why we should continue using the U.S.
Because so much more convoluted, so much more. But we don't want to do it in 2020. I don't think we want to tackle that one in 2020. Maybe next year.
We need to wait another 30 years or something.
We've gone through enough this year. Just tack it on. It's just one more extra thing.
All right, one more extra thing. Okay.
You're trying to destroy something, destroy our culture or something.
If you talk to any of the many people that, well, I guess there were 9 people that didn't show up today. Oh my, it just makes me so sad. You know, I just don't know what to say. But,
keep going in the direction we may not have to worry about the U.S. thing anymore.
Yeah. Okay, so, and also take advantage, you guys, anyone that's in here, look over your test, you know, text me, email me if you want to go over it at some time. I'm happy to do that with you. We want to help you. We want you guys so much. I mean, I can't even tell you how much we want you to be successful. It hurt, you know, when you don't do well, puts me in a bad mood so much. My husband doesn't even like me. So just, we really want you to be successful.
Yeah, I would say like, and there are a few people that are doing what they're supposed to do.
Absolutely.
And I appreciate you, and I appreciate
Me too.
you like leading the group and everything. Don't think we're not noticing you, right?
No, we are. If you made an A or even a B on this last test, you are a rock star. So we appreciate you. And the rest of you, you can do better. I promise. We just have to.
But there's a few quiet blank screens that don't come around, and it's like you can do what you want, like you paid for this class, but
yeah, but
that's
you're
not it's not gonna get you through it.
You will not pass if you don't do it here. It takes a lot. It's and it's every day, every single day. So that's my lecture. But okay. Think of me as like your mom. You can, or your grandma. You can come to me anytime and I will help you. And Matt's like your big brother, maybe.
I'm Uncle Matt now.
Uncle Matt.
Yeah.
All right. Okay. All right. If there's nothing else, I'll be here for a little while after class. So hang in there if you need to talk to me about anything. Otherwise, you're free to go and work on the assignment. And I will post, I think I sent them to you, or I have some more practice problems that would be good for you to do. So I'll post those on Blackboard.
Thank you.
Yeah.
Thank you,
Y'all
Ms. Susan. Have a good one.
You too. Bye-bye.
Have a nice day, guys.
Okay.